Lagrangian equation of motion. Now here Lagrangian L is equal to T minus V, where T is the kinetic energy and V is the potential energy, and we can write the Lagrangian equation of motion as d by dt of dou L by dou q dot minus dou L by dou q is equal to 0. Now this is the Lagrangian equation of motion unless there is any constraints which are non-conservative. If there is a force due to constraint that is non-conservative, then the right hand side will become a non-zero quantity. Now what we want to focus here is for every generalized coordinates, there exists a equation of motion, that is Lagrangian equation of motion. Corresponding to each generalized coordinates, there is a equation of motion. Just for example, let's consider a Cartesian coordinate system. Where particle moves in any direction, for example in x, y, z direction without any constraint. Now Lagrangian is given by T minus V, so we are assuming that in all direction it has the velocity, so half m x dot square plus y dot square plus z dot square. This becomes the kinetic energy of the particle in all three direction, minus v of z. We are assuming that the potential is only along the z direction. Now here all generalized coordinates are x, y and z, and taking the first generalized coordinates x, corresponding to x there is an equation of motion, Lagrangian equation of motion, given by d by dt of dou L by dou x dot minus dou L by dou x equal to 0. Now d by dt of dou L by dou x dot is d by dt of dou L by dou x dot is nothing but mx dot minus dou L by dou x, there is no term, so that's equal to 0, which implies mx double dot equal to 0. Right, so this is the equation corresponding to the generalized coordinate x. Right, now similarly with respect to y, we have my double dot equal to 0, and with respect to z it is mz double dot and here you will get one more term corresponding to dou L by dou Z, because our V is a function of Z, so that would be so we write dou L by dou Z. So dou L by dou Z is dou by dou Z of V of Z, so minus this quantity. So dou L by dou Z is minus minus dou by dou Z of V of Z, right? Because it's so equation goes like this: d by dt of dou L by dou Z dot minus dou by dou Z of V of Z, right? So dou by dou Z of V of Z will be remaining as it is, and this will be minus, right, dou L by dou Z, so it becomes plus dou by dou Z of V of Z. So this is the equation of motion corresponding to Z direction. Now coming to spherical polar coordinates. Spherical polar coordinates, we have the Lagrangian given by half m r dot square plus r square theta dot square plus r square sine square theta phi dot squared. Now what is the Lagrangian equation of motion? That is, for r we have d by dt of dou L divided by dou r dot minus dou L by dou r equal to 0. Now let's find out what is d by dt of dou L by dou r dot. So dou L by dou r dot is equal to d by dt of, now dou L by dou r dot, so with respect to r dot you are differentiating, so r dot 2 times r dot m into r dot, so that means m r dot. So this gives us m r double dot. Now you need this quantity here, so dou L by dou r, so that's equal to dou by dou r of, now we need L here, so half m r dot square plus r square theta dot square plus r square sine square theta phi dot square, and okay, we'll also write the potential term which is depending on V of r. Okay, so this is fine, dou by dou r of this minus V of r. So the entire term we have to differentiate, so this becomes dou by dou r, the first term doesn't have r, so here we have r, so 2r theta dot square, so m r theta dot squared. Now again here you have r square, so that plus m r sine square theta phi dot squared, and again here you have minus dou by dou r of V of r. Okay, so this is dou L by dou r. Now we add, sorry, this is 1, this is 2. Now from the equation of motion, d by dt of dou L by dou r dot minus dou L by dou r. So equation 1 minus 2 should give us the equation of motion. So 1 minus 2 gives you the equation of motion in such a way that m r double dot minus mr theta dot square minus mr sine square theta phi dot squared plus dou by dou r of v of r equal to 0. So this is the equation of motion corresponding to r. Coming to the second coordinates, that is theta. With respect to theta, we can write the equation of motion as dou L by dou theta dot total time derivative of dou L by dou theta dot minus dou L by dou theta as equal to 0. Now d by dt of dou L by dou theta dot is equal to, so take the theta dot here, so 2 theta dot, it is theta dot r square theta dot m, so that is d by dt of m r square theta dot is the equation. Now we have to differentiate this. M r square theta double dot plus, so here we have to differentiate with respect to r also, so 2m r r dot theta dot, so this is dou L by dou theta dot. Okay, so now we have dou L by dou theta given by so dou L by dou theta means you need to consider only this per term, so half m, so theta sine square theta differentiation is 2 sine theta cos theta, and m r square will remain, so it is 2m r square sine theta differentiation, so it would be sine theta cos theta. Because 2 sine square theta d by d theta of sine square theta is equal to 2 sine theta cos theta. So m r square sine theta cos theta and phi dot square will be here. Now we will write the equation of motion. So this is the first term, this is the second term which with minus sign, so 1 minus 2 gives the equation of motion corresponding to theta, so that's equal to so m r square theta double dot plus 2m r dot theta dot minus m r square sine theta cos theta phi dot squared. Now since potential V is a function of r alone, d by d theta or dou L by dou theta of V of r will be 0, right? So this is the equation of motion corresponding to theta. Now coming to the third generalized coordinates, that is phi, we can write the equation of motion d by dt of dou L by dou phi dot minus dou L by dou phi equal to 0. Now dou L by dou phi dot is equal to, so this is the only term which contains phi dot, so to phi dot, so r square sine square theta phi dot with m, so m r square sine square theta phi dot equal to dou L by dou phi dot m r square sine square theta phi dot, and its time derivative d by dt of dou L by dou phi dot equal to m r square sine square theta phi double dot plus m r square. So now we need to differentiate sine square theta, so it becomes 2 sine theta cos theta theta dot plus with respect to r m 2r r dot sine square, here we have phi dot also, theta dot phi dot, so m sine square theta phi dot. So let's rearrange this. This gives us m r square sine square theta phi double dot plus m r square 2 sine theta cos theta theta dot phi dot, so 2 m r square sine theta cos theta theta dot and phi dot plus 2 m r sine square theta r dot phi dot. So this is d by dt of dou L by dou phi dot. Now dou L by dou phi is equal to, so let us look into where is phi. There is no term consisting of phi, and v is a function of r alone, so dou L by dou phi is 0. So equation of motion is only these terms, so equation of motion will be m r square sine square theta phi double dot plus 2m r square sine theta cos theta theta dot phi dot plus 2m r sine square theta r dot phi dot equal to 0. So this is the equation of motion corresponding to phi. As a further practice work, for practice you can consider the Lagrangian. First one, in polar coordinates you can have Lagrangian as half m r dot square plus r square theta dot square minus v of r. Now second one, you can also consider the cylindrical coordinate system, which is consisting of rho, phi and z. L is equal to half m rho dot squared plus rho square phi dot square plus z dot square minus v of z. So these two work you can take up, and here you have generalized coordinates as r theta, and here we have generalized coordinates as rho, phi and z. Here we have a question. Question is find the equation of motion. Find the equation of motion for each generalized coordinates. For each generalized coordinates. So what is given as the Lagrangian is L is equal to half m x dot squared minus half omega square x square minus alpha x to the power 4 plus beta x dot x squared. So now this is the Lagrangian, and this part gives the kinetic energy, which is T, and this session is regarding the potential energy V. So potential energy is a function of x square as well as x dot, which is velocity. So it's a velocity dependent potential. So now with respect to x, we need to find out the equation of motion. So this equation of motion, let us write down d by dt of dou L by dou x dot minus dou L by dou x. So this is the equation. So let us write down what is dou L by dou x dot. That's equal to half m x dot. So m x dot and another term which consists of x dot is this one. So plus beta x squared. So dou L by dou x dot is mx dot plus beta x square, and d by dt of dou L by dou x dot gives us mx double dot plus 2 beta x dot. With respect to time, we are differentiating this quantity. Now dou L by dou x is equal to this is half omega square x square, so 2 omega square x square, so that is omega square x and with a minus sign, and here you have again minus sign, 4 times alpha x to the power 3 plus 2 beta x dot x into x dot, so that is 2 beta x dot and x, so x and x dot. So this is dou L by dou x. Yeah, now this is 1 and this is 2, and we have to subtract 2 from 1, so 1 minus 2 gives you mx double dot plus 2 beta x x dot. This becomes plus omega square x plus 4 alpha x to the power 3. Again here you have minus 2 beta x x dot. Now this is 2 beta x x dot with the plus, this is 2 beta x x dot minus, so this gets cancelled. So equation of motion will be mx double dot, this gives you 0, so mx double dot plus omega square x plus 4 alpha x cube equal to 0. So this is what is the answer. For the practice work, you can consider this as the question. Lagrangian, L is equal to half m r dot square plus r square theta dot square minus mgr cos theta. Here generalized coordinates are r and theta. You can find out the equation of motion corresponding to r and theta. Another work, Lagrangian is equal to half m r dot square plus r square alpha square minus mgr sine alpha t. Third question, Lagrangian is equal to half m r square theta dot square plus mgr cos theta plus half m r square omega square sine square theta. Fourth, Lagrangian is equal to half m r dot square cosec square phi plus r square theta dot squared minus mgr cot phi. L is equal to half m rho dot square into 1 plus a square rho square plus rho square phi dot squared minus mga rho square by 2. Find the Lagrangian equation of motion for the Lagrangian L is equal to e to the power gamma t times half m q dot square minus half k q squared. So this is the Lagrangian given. We are asked to find out the equation of motion. Now here, first of all, we need to find out what is the generalized coordinates. The generalized coordinates is q, and corresponding to q we have the equation of motion, total time derivative of dou L by dou q dot minus dou L by dou q equal to 0. So dou L by dou q dot is equal to e to the power gamma t times mq dot, so that's dou L by dou q dot so here we need to write d by dt. So d by dt of mq dot, yes, so that's equal to wait, we have made a mistake here. So dou L by dou q dot is equal to e to the power gamma t into mq dot. Yeah, so this is dou L by dou q dot, and d by dt of dou L by dou q dot is equal to u into uv, so u into derivative of v and derivative of u into v. Now e to the power gamma t into differentiation of mq dot is mq double dot plus differentiation of e to the power gamma t, so that is e to the power gamma t times gamma into mq dot. So this becomes the first term, and what is dou L by dou q? Dou L by dou q is e to the power gamma t into half k q square, so minus k q, so that's equal to minus e to the power gamma t into kq. So equation 1, 2, so 1 minus 2 gives us the equation of motion, that is e to the power gamma t into mq double dot plus gamma times e to the power gamma t into mq dot plus e to the power gamma t into kq. Now equal to 0. Now you can take this e to the power gamma t out, and this becomes mq double dot plus mq dot plus kq equal to 0. Sorry, there is a gamma here, plus gamma mq dot plus kq equal to 0. You can write down as few questions as practice work. Lagrangian is equal to m square x dot to the power 4 by 12 plus m x dot square into v of x minus v square of x. Second, Lagrangian is equal to half m plus 1 plus 4 v square x square x dot square minus mgx square b. So third, Lagrangian is equal to half m x dot square plus y dot square plus z dot square plus m omega into xy dot minus x dot y plus half m omega square into x square plus y square. So here you have x, y and z as the generalized coordinates. Fourth, Lagrangian is equal to half m r dot square plus r square theta dot square plus g m by r square. That's the fifth question. Lagrangian is equal to half m x dot square minus kx to the power 4 by 4l square